So we've got Scott and Castel. So I'm calling him Castel. Maybe it's Castle. No, it's Castel. So Scott leaves the airport, and Castel leaves the airport. Now let's see. Castel is going at 50 miles per hour. So that's Castel's rate. And it seems that the time that Castel travels for is 2 hours. What do we know about Scott? Scott is traveling for 3 hours to start with, and then an additional 2 hours as Castel tries to catch up with him. So he's got 5 hours worth of time. Now, continuing with this, let's see. We want to get Scott's average speed. So let's solve what we can solve for Castel. So we've got the distance is the rate times the time, which is 50 times 2, which is 100 miles. So now we know Scott's distance is his rate times his time. And so continuing with that, we know that he goes a total of 100 miles to get to the train station as well. We don't know his rate, but we know he's traveling for 5 hours. So when we simplify that out, we're going to get that Scott's rate is 20 miles per hour. And then we have Jose traveling to the town hall and back, 5 hours there, 4 hours back. He averaged 35 kilometers per hour on the return trip, and we want to find the average speed of the trip there. So this is very much like problem number 2. So let's be clear. Let's do the time back is 4 hours. The rate back is 35 kilometers per hour. So let's get the distance back, which will be the same as the distance out. That's going to be rate times time, which is 35 times 4, which is going to give me 140 kilometers. And now we want to figure out the average speed of the trip out there. So distance out equals rate out times time out. And that's going to be 140 because the travel distance there is the same as the travel distance back, equals the unknown rate times a time of 4 hours. We divide both sides by 4, and what we'll end up getting is 35 kilometers per hour as our rate out. So this is problem number 4, and in the next video I will do problem number 5.